This is the example of the declaration of a one-dimensional array. So here integer is a data type and age is an array name and 5. So array size is 5. That means, so this array is going to declare the age to store integer ages of 5 people. Okay. So the array elements of age are as given in the figure. Okay, so assume that age of 0 is stored in memory address 1000 and then age of 1 is stored in the memory address 1002 and so on. So why we are using 2 bytes for each and every location means, since we are using the data type integer, so integer occupies 2 bytes of memory location. And here, so the memory location, the adjacent memory locations are filled for the 5 locations, so given that age is of the 5 persons, so that's why we are taking the 0 to 4, right? So the memory locations will start allocating from 0 to 4. Okay, and each location is occupying 2 bytes of data, because so this is of a data type integer. Suppose if you are using the data type float, it will occupy 4 bytes of space. Similarly, if you are using the char data type, then it will occupy 1 byte of space on the memory location. Okay, and here, so randomly the memory allocation will be allocated here. The address that we are assuming here is 1000. Okay, so the allocation of the age is started from the memory location 1000, which is randomly assumed by us. Okay, so 1000, 1002, 4, 6 and 8. Suppose if you want to access the age of the second person, okay, if you want to access the age of second person, then you have to access the memory location 1002, that is age of 1. Okay, so here the memory location subscript is of 0, 1, 2, 3 and 4. Okay, so this square brace is called as a subscript or index value. Okay, okay, the square brace is the subscript and the value inside the square bracket is the index value. Okay, here the index value for the first one is 0 and for the second age is 1 and third age is 2 and fourth age is 3 and last one is age of 4. Okay, so this is the index value. And if you want to access the first person, okay, first person age means that is age of 0, and if you want to access the third person age, then age of 2 must be accessed. Okay, so this is the declaration of the one-dimensional array. So let us see the initialization of the one-dimensional array. So it can be done, the initialization of one-dimensional array can be done in 2 ways. In the first method, its declaration is a single statement. In the second method, it is done by declaring and initializing separately. So let us see the first method here, that is declaration. So this is the syntax for the declaration in a single statement, and we know that the syntax of the size. Okay, so here we are giving the values. Suppose if the array size is 3, then we have to give 3 values. If array size is 5, we have to give 5 values here. Okay, and this is the example of how this single statement, how the declaration is done in single statement. So int age of 5 persons we are storing, and this is the values, and the values will be stored in a sequential fashion starting from the index value 0. Okay, so 20 will be stored in 0, 15 will be stored in age of 1 and so on, and 43 will be stored in age of 4. Okay, so with the index value 4, the last one will be stored. Okay, and the second method is declare and initialize separately. Okay, so in the previous method we have declared and in a single statement here. Okay, so we are sequentially assigning the values, but here we are going to assign the values to the particular subscript separately here. Okay, data type, array name and array size we are giving as syntax, and array name of 0 equals to value 1, and for the index value 1 with the subscript is value 2, and n minus 1 subscript is value n. So like this we have to assign the values for each and every memory location separately. Okay, so like this it will be done. So int age of 5, so age of 0 equals to 20. Okay, so for the index value 0 we are assigning 20, and age of 1 15, age of 2 35, age of 3 54, and age of 4 43. Okay, and here for each and every person age, it will occupy 2 bytes of data because we are using the data type integer here. Okay, similarly if you use the float data type, then it will occupy 4 bytes of data like this. So here I am giving the so here there are only 6 values given. 6 values are given here: 20.0, 30.5, 40.3, 50.0, 60.5, and 67.9. So these are 6 values only given here, but the assigned memory location is of the 10 memory locations is assigned here. Okay, so if you are not assigning some values for the given locations, then it will assume the values as 0. Okay, so it is going to assume the values as 0 if the user is not mentioning the values. Okay, so in the above statement declares an array B to store 10 real values and initializes the values as given in the array. So while initializing the array B, so we have specified only 6 values, and the other values will be treated as 0.0 automatically. Okay, and similarly if you are going to store the char data type, then it is going to assign 1 byte of data for each and every location. Okay, so since we are using the float data type, so it is going to assign 4 bytes of data for each and memory location. Okay, and here, so since we are using the arrays, so arrays can store only homogeneous data types. Okay, so here it is in the given array B, so it is going to store only float values. Similarly here in the array age, it is going to store only ages of 5 persons in the integer format only. So like this it is going to store only values of a particular data type. So next one is accessing one-dimensional array. So now we have seen the declaration part and initialization of the one-dimensional array. Okay, so once the array is declared or initialized, we have to know how to access the individual elements of an array. So in the array int age of 5, the array name is age and its size is 5, which means that it can store 5 ages of the persons, and we cannot get access to all the 5 values just by mentioning the array name, that is age. So to access the individual elements of the array age, one should have an idea about the array elements. Okay, the array age is having 5 elements with the subscripts 0 to 4, which is given here. So we are having the subscript 0 to 4. So these are called as the subscripted values. Okay, so generally to access the element of an array age of n, so we should write age of I, where I is 0 to n minus 1, that is n is 5, right? So 5 minus 1 is 4. So consider the statement here, age of 5 equals to some set of values assigned here. Okay, suppose I want to access a particular person's age here. Okay, so I want to access the age of the person, that is third person. I want to access the age. Okay, so then I can write, so here the third person age is 35. Okay, so to access the age of the third person, we have to write the statement like printf %d backslash in age of I. So in the subscript value we have to give mention the particular age of the person. Here if you want to print the age of the second person, then you can give the subscript as age of 1, then it is going to print the age of the second person. Okay, so here using the for loop here, so you can print the ages of all 5 persons. Okay, so similarly here, if you want to take the, if you want to read the ages into the array, then you can use the scan of %d and age of I, then it is going to read the particular age of the person into the memory location. Suppose you want to give the age of 0, so age of the 0, so 0 1 2 3 4. Okay, so you can enter the age of the 0th person, that is the first person, as 20 here using the scanf function. Similarly 15, 35, 54 and 43. So by using the scanf function we can read all the ages of the persons into the array. And we can input values for the five persons age, and then I'm going to print them using this for loop. Okay, so for for reading the input here, I'm using the for loop for I equal to 0 to 5. That means to print the ages of 5 persons. So 0 to 5 means, so it is going to take 0 to 4. Okay, so the ages of 5 persons, and enter the age of the first person, second person, and so on. It is going to store the value in the age subscript here, starting from 0 to 4. Okay, so here given that I less than 5, not I less than or equals to 5. So I less than 5 means it is going to take only 5 values, 0 to 4. Okay, so after that one, it will start printing the elements that it has read from the user. Okay, so here the printf age of I, so it is going to print the age of the 5 persons starting from the first subscript to the last subscript. Okay, so now let us execute this program here and see the output, how it is going to access the one-dimensional array. So it is asking to enter the age of the first person with the subscript 0. Okay, I equals to 0 to 4, right? So it will ask from the ages of it is going to store the ages of persons from 0 to 4. So I'm going to enter the age of the first person as 23, 34, 56 and 29, 31. So it is going to print the elements which has been read from the user as input. So it is going to print all the values it has read from the user. Okay, like this. So press any key to continue. So this is about how the accessing of one-dimensional array will work. So this is about the one-dimensional array. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.